Hello dear students, hope you all are fine. In the last class, we discussed different forms of integration by partial fractions. Today, we discuss integration by parts. So, here the problem is when you are given the integrations as the product of two functions, then what we can do? We have integration of this form, that is f of x and g of x dx. That time what you can do? We have so far no prescribed rule for the product of two functions, but we have the derivative rules that we called product rule. Suppose we have the derivative of these two functions, that means derivative of f of x and g of x is equals to, that is f of x derivative of g of x plus g of x and the derivative of f of x. F of x, this rule we know as the product rule. When two functions are in the form of product and we have to find the derivative of that two functions, that time we use derivative product rules. Now, if the case arises for integration, then what we can do? We have a particular rule for finding that integration, and that rule is called integration by parts. So, today our topic is the integration by parts. Now, I show how can we find the integrating by parts formula. This formula can be derived by using the product rule. Let us take the product rule. Here the derivative of two function f of x, g of x is given as f of x derivative of g of x plus g of x and derivative of f of x. Now, if I take integration on both sides of this product rule, then integration, that is derivative of f of x and g of x, that will give you integration of f of x derivative of g of x plus integration of g of x and derivative of f of x. Now, dear students, you look here. This part is what? When we take the derivative as well as integration, that means that will simply you will get f of x and g of x from here, and this is equals to integration of f of x derivative of g of x plus integration g of x derivative of f of x. Now, I want to shift this part to the left hand side. That means you have f of x, g of x minus integration of g of x and derivative of f of x is equals to integration of f of x and dx of g of x. Now, let us assume this f of x as u and the derivative of g of x, that means derivative of d upon d by dx of g of x as v. Now, if I replace this f x by u, derivative of g x we replace by v, then what happened? Look here, we have, this is implies we have f of x, that means you have u here, and that is g of x. G of x means if you have derivative of g of x is this one, so simply g of x is nothing, it is the integration of g of x is the integration of, that means of v. So, f of x is u, that I replace here, that in place of f(x) and g of x, but we have derivative of g of x is as v, that means g of x is the integration of v. So, that means u and this gx can be replaced by integration of v minus integration, and this is again that is g of x and derivative of f of x. F of x we can write f dash of x, that is the derivative of x, and here g of x is again integration of g of s is again integration of that is v, and I keep this v as dx, here I also keep as dx. So, is equals to, here it will be f(x) as u and derivative of gx as v, so, and dx, that derivative of dy dx is replaced as dx, here dx. So, ultimately what the formula we have? We have integration of u into v d of x is equals to u integration of v of dx minus integration and then derivative of u integration of v dx and dx. These formula we know as the integration by parts. Here u into v, that means two functions are in terms of x. Two functions in terms of x will be given to integrate or as the integrand, and we have to use this formula, that is u integration of v minus integration derivative of u and integration of v. Here you can also read like this, that is you can say as first function, you keep this integration sign as it is, you tell this u as first function and the second function, and we have to take the product of this first function and second function. That means the formula is what, or integration by part means what, that is first function will be here, integration of second minus integration for the overall parts, and this is derivative of first function and integration of second, and dx is here. This rule also you can write in this way, first function and second function. Okay. So, this by integration by using this formula is known as integration by parts. Here we use this formula when two functions are given in product form. That means your integration, your integrand is in product. But dear students, here to choose the first function and second function is very important. Always the function which are given in the first position, that is not taken as first function. We have to choose in such a way that we know the derivative and integrations of that functions. For example, suppose you are given as x log x, here your I integration of x log x dx. Here the two functions are, one function is x, another function is log x, and both of them are given in product in the integrand. So, we want to find, so obviously you have to use this integration by parts formula, but your choice is important here. Which function you have to take as first function and which one as second? The first function, obviously you look here, you must know the derivative of the first function. The function whose derivative is known to us, that must be taken as first function. Okay, because we have to perform the differentiation over the first function. Nowhere we perform any integration over the first function in this rule or in this formula. Look here, first function integration of second, but we are doing the differentiation over this first function here. So, that means you have to choose in such a way that you must know the derivative of the function, such function will be taken as the first function, and the second function Obviously, you look here, integration of second, that means the integration, the function whose integration will be known to us or who is known to us will be taken as second function. Okay. In this case, we have x, we know the integration as well as derivative of this x, but we can choose this x as first function, as second function, because we know the derivative as well as integration of this. But what about log x? Log x, we do not know the integration of log x so far, but we know the derivative of log x. That means obviously the derivative is known, that means that will be taken as your first function. Okay. So, first function will be taken as log x and the second function will be taken as x. So, like this way or this particular method to be followed to choose the first function as well as the second function, but some not a certain one, but here I will give you one idea or an preference of selecting first function of second function. Suppose the functions, I take all these functions, first letters of all these functions, that means I am taking trigonometric functions as t, inverse trigonometric function as I, exponential function as e, and I make a sequence of these letters, then I get a word islet, I, L, A, T and E, islet. This I means what? Inverse trigonometric functions, L for what? Logarithmic functions, A for what? Algebraic function, T for trigonometric and E for exponential. In the most of the cases, we can follow or we can select our first function and second function by using this islet, the functions which will be given in such sequence that we can take as first function, as second function. As I have given you the last example here, integration of x log x, that means here x is the algebraic function. So, algebraic function and logarithmic function, these two are given here. So, logarithmic function in this islet sequence, L is coming first. So, we take a logarithmic function will be as our first function and this will be second function, that I already told you. That means we have to select our functions in respect to this islet form. In most of the cases, in maximum cases, you can think that your problem will be solved. Okay, dear students, here some problems will arise where the product will not have the integrations. That means the integration will not be possible by using this integration by parts formula. That means sometimes some questions will arise there the integration by parts will not work. I may give you one example. Suppose you are going to assume such an example, that is integration of root x cos x. Such type of integrations is little difficult by using this one, even it is given in product. That means what? That means every functions cannot be integrable by using this one, by we have to follow or you have to find out some other rules for that. Okay, dear students, now come here. Here in this formula, how many times this integration signs appear? So, that means 1, 2 and 3 times. This is first integration, this is second integration and finally, we have to do the third integrations. That means there will be 3 constants. Every time the integration will give you one constant. So, every time you have to write C, but no need to write C every time here. We only write C in the final result. Okay. That means integration of second here and integration of second once again here and integration, overall integration. 3 times you have to perform the integration in this by using this formula, but every time you need not write C. You write your C in the end or in the last final result. Okay, dear students, I think it is clear. Now, when we use this one, we use only when the functions will be given in product, but some different cases are also there. That means some functions like logarithmic functions and inverse trigonometric functions. In such functions, till now we do not have the integration. We want to find the integration of log x or integration of sine inverse x or integration of tan inverse of x. So, these all are not yet result with us. So, we can find the integration of these functions, especially this logarithmic function and inverse trigonometric functions, by using this one. But question is what? Here it is, you can see this one can be used as the product of 2 functions, but here it is only one function. So, how can we take the integration by parts over here? No problem, you can assume one here, that means one algebraic constant, and that you can take as 2 functions. Now, one is one function and log x is another function. Now, according to Eilert, again you can assume this logarithmic function as your first function and 1 as your second function, because your 1 is constant and that will be taken as algebraic one. Similarly, in this case or in this case, what we can do? It is inverse function in the Eilert form, it is given in the first position, that means we must assume this inverse function as your first one and your 1 will be here. I show you one by one. Integration by parts is what? That means product integration of the product of 2 functions, and that will be first function integration of second minus integration derivative of first integration of second and finally dx. So, this is the integration by parts. Okay. Let us see the problems. Now, first we take the integration of log x. Okay. Integration of log x. As I told you, you have to take as 1 here and this is log x and dx. According to Eilert, your logarithmic function is coming first in the Eilert. So, you assume this is as first and this is as second. So, according by integration by parts, integration or integrate by parts, we get what you get, that is first function, your first function is log x, integration of second, that is 1 of dx, that means simply I write dx, this is I equals to log x integration of dx minus integration, I now keep in bracket, that is derivative of first, that is derivative is your log of x, and integration of again second function integration of second, that means 1 of dx, that is dx, and that is dx is closed here. Now, what happened? That is log of x, integration of x, integration of 1 of dx or simply dx is x. So, you have x log x here minus integration derivative of log x, that you all know, that is 1 by x, and integration of dx is again your x. So, here it is dx. So, x log x minus this x will cancel. So, you will have integration of dx only. Now, x log x minus of x and this is plus c. So, that is your final result, or integration of log x is equal to x log x minus x plus c. This way you can find the integration of log x. Now, we know the derivative as well as integration of log x. Derivative of log x is simply 1 by x, and whereas integration of log x is what? X log x minus x and plus c. Okay, same way you can find the integration of sine inverse x. I equal to, let us take sine inverse of x dx. Now see, here only we have the sine inverse x, that means you can take 1 here as a constant, algebraic constant. So what? You have taken as 1 sine inverse of x and dx. So here it will be taken as your second function, it will be taken as your first function. So according to islet, you can compare with the islet, you can compare with the islet. I means inverse, that is in the first position, that means you are taking as this is the first function and this is the second function. So apply integrating by parts, we get what you will get. First function, that is I, is your first function, that is sine inverse of x, integration of dx minus integration, that is derivative of first function, that is sine inverse x, of integration of dx, and bracket close, we have dx here. Now this is sine inverse x and integration of dx, that means x sine inverse of x will be here, minus integration derivative of sine inverse x. I think it is very much clear to you all, that is derivative of sine inverse x is what? 1 upon under root of 1 minus x square, and into this is dx, that means you have x here. So x and dx, overall I keep this dx here. So this is equals to x sine inverse of x minus, we can write, that is integration of x under root of 1 minus x square and dx. Now you have to perform the integration separately of this one. Okay. Now see, I can write this is as x sine inverse of x minus of I1. Here you have I write it as I1. Now where this I1 is what? Where your I1 is nothing but the integration of x upon under root of 1 minus x square and dx. Now I can perform the integration of this one separately. So you have the rules previously, the substitution rules, the bifurcation rules, or partial fraction rules, or even some adjustment you can do it over here. So let us see what we can do. Suppose if you put this full as t, then derivative will be what? Something of x will be there in the derivative, that means it can be replaced. We can put t. Let us see. Okay, putting, now I do the integration of this I1, putting t equals to some 1 minus x square, that means your dt will be what? That is minus of 2x and dx. This is equals to minus 1 by 2 dt is equals to x of dx. Therefore, your I1 can be written as integration, that is x dx can be replaced by minus 1 by 2 and dt and under root of t. Now we all know the under root of t integration is what? That we can write 1 by 2 into 2 times of root t, and you can write C1 here also. So that means this 2 will cancel. So you will have minus root t plus C1. So that means minus, and your t is what? What we have assumed? We have assumed as t as 1 minus x square plus C1. Now therefore your I or main integration I is what? Your main integration I was x sine inverse x minus of I1. So now I can write it as x sine sine inverse of x minus I1. I1 is again you have minus of under root of 1 minus x square, and overall for this integration, this C1 and the remaining constants togetherly I can write this C. So, finally, that is x sine inverse of x plus root under 1 minus x square plus C. So, that is the integration of sine inverse x. That is the integration of sine inverse x. So, this way you can find the integration of inverse function as well as the logarithmic function. Okay, now I show you one more type. Suppose you are given integration of sine log of x. Such type of problems are given. Sine log of x, that means by differentiation we have to use the chain rule here, sine log x, but here it is given in function into over a function. Okay, function over a function, we must use the chain rule for the differentiation, but what about integration? For the integration again we have to use the integration by parts. Here what to do? Here this is full as your one function. So, you take as constant 1, again similar procedure. Now, here we take this 1 because we know the integration of 1 is x. We cannot take as first function because derivative will be 0, then no use. So, simply we take this is a second function and this part is your first function. Okay. So, yeah, as per rule we go first function, that is sine log of x and integration of dx minus integration derivative of sine log of x and integration of dx, that is the dx here. Now, this is equals to sine log of x and this x is, this derivative of this dx is nothing but x minus integration, that is derivative of sine log x. Sine log x is cos log x, and for that log x is 1 by x. So, I put here 1 by x, I put here 1 by x, and for this one is what? And for this one we can write x, and dx we have also. This x will cancel out. So, definitely you will have x sine log of x minus integration of cos log of x and dx. Now, again you have to perform the integration by parts over here. So, that will be x sine log x minus I keep here, and this is again your first function is what? That is cos log of x, integration of second function, that is simply dx, and I write x is here, and minus integration, that is the derivative of cos x, and derivative of cos x is minus of sin x, and minus of sin x, sin log x, and 1 by x, and integration of x is here again x, and that is dx. Okay. So, this is equals to x sine log of x minus this is x cos log x, and this minus will give you plus, once again you have the minus sign here, that minus this x cancel, and you will have integration of sine log of x and dx. See dear student, this part, look at this part very carefully. This part is what? This is nothing but similar to your I. This part is nothing but similar to your integration of sine log of x, that is sine log of x. That means this part you can replace by this I. So, by replacing this sign, you have I is equals to x sine log of x minus x cos log of x, and that is minus I. This I can shift to the left hand side, and that is this I, when I shift into the left side, that is 2I is equal to x sin log of x minus x cos log of x, and that is I is equals to 1 by 2 times of x, you can take common, sin log of x and minus of cos log of x, and that is you can put on C here also. That is the answer. That is I equal to 1 by 2 times of x sin log x minus cos log of x and plus C. So, this way you can find the integration of some functions. So, dear students, today we have discussed the integration by parts, and I think it is very much clear to you and you have enjoyed the lesson and practice well, and we do the some more questions in the next class. Thank you.